Hello, I'm Toby from the DJI Enterprise team, and I'm up here today on the roof of this building to help a customer plan their rooftop solar installation. The owners of these buildings want to install solar on all the rooftops to harness the power of the sun and generate electricity to meet the needs of about 2,000 families. A project like this requires careful planning, involves many preparatory steps like precision surveying, and it can take up to 3 months. Throughout this process, drones are a crucial technology. Today, we'll be flying the Mavic 3 Enterprise to demonstrate how drones are essential tools in the planning stages of solar construction, and to show just how much efficiency they bring to the job. We can break down our fieldwork into 6 steps. Before we start installing solar panels, we need a plan. How many solar panels do we need? How much surface area will we cover? And where exactly will each panel be installed? To plan this, we need to measure the dimensions of each rooftop, as well as the height of objects like the walls, external air conditioning units, or anything that will cast shadows, obstruct the solar panels, and affect power generation efficiency. Additionally, our measurements need to meet the requirements of our client, which is a 3 centimeters per pixel GSD, because they need to take into consideration features as small as drainage ditches and water pipes. To get these data, we need a detailed 3D model, which we can generate with a drone. Next, we need to find an ideal takeoff point. Considering transmission distance, return to home route, flight time, and other factors, a higher location at the center is a good choice, which can also let us observe the aircraft during the mission. If the operation area is large, multiple takeoff points can be selected using the same principles. Once you finish your current flight, you can move to the next takeoff point and repeat until you completely cover your target area. Next, we need to identify any risk zones. Manually fly the drone above potential hazards, such as tall buildings and trees, and mark each location using the pinpoint feature. Then, fly along the boundaries of your mission area, mark the edges, and confirm that the transmission signal is stable. If the transmission signal is disconnected by nearby obstacles, you can replace or add another takeoff point. Once we've identified our mission area boundaries, any potential risk zones, and a suitable takeoff point, we can begin our mission planning. Taking into consideration the risk points we identified, divide the operation area into safe zones and risk zones. Create missions for each separately, select the aircraft, and set the mission name. Select Mapping Mission with Smart Oblique feature enabled for the safe zone. Set the route altitude according to the required accuracy or GSD, and keep other settings as default. For each risk zone, you'll need to plan 2 missions. The first is a mapping mission at 37 meters without Smart Oblique to ensure there's no outreach area. The second is a mapping mission at 80 meters with Smart Oblique to capture more photos from multiple angles. Execute the mission respectively for the safe and risk zones. Be sure to pay attention throughout each mission. If an emergency arises, you can always press the pause button to stop. If you want your final model to have more detail, you can manually shoot key areas, either in a straight line or a circle. In this case, we reduce the max flight speed to 2 meters per second, use 1 second time interval shooting, and set our gimbal angle to -45 degrees. By limiting max flight speed, you can hold the control stick all the way down in the direction you want to fly and ensure consistent flight speed for equal interval shooting. After the mission, transfer the data to a computer for backup. If you're worried about data loss by drone accident, you can make a backup every time you swap the battery. After completing our fieldwork with the above steps, let's take a look at how to process our data back at the office with DJI Terra. Before you start, make sure your PC meets the following requirements and that your license is Pro or above. Open DJI Terra, log in with your account, click New Mission, Visible Light, edit the mission name, and import all the mission folders. Keep the settings as default, click Arrow Triangulation, after finishing, open the 3D model, select Advanced, and click ROI. Click Editing Mode, add the corners of the area, then click Back and Apply. After that, you can go back to the previous tab. Select the 2D and 3D model tabs. You can keep the other settings as default if there are no other special requirements. If you want to collaborate with other software, you can select the file format you want to export. Click Reconstruction and DJI Terra will start working. If you're not satisfied with the results, you can manually shoot specific areas and reconstruct the model again. Finally, now that we have our 3D model, there's a few things we can do with it: measurement, design, and inspection. For measurement, enter the model, click Annotation and Measurement, choose Distance or Area, then you can left-click to select the target and right-click to see the result. For design, you can export the model and use other software to create a CG. For inspection, you can use DJI Terra Electricity Edition to plan a detailed inspection flight route and make the daily work more efficient. Stay tuned for a video on this in the future. And there you have it. We hope this M3E survey workflow has been helpful and that you can refer to it in the future when conducting your own site surveys. If you like this tutorial, be sure to check out the DJI Enterprise channel for more videos. See you next time.